Welcome friends. In this video we are going to look at science paper 2, and our focus is on random questions that involves organic chemistry. So let's look at our first question. The table below shows some information on two polymer. So what is a polymer? So if you look at a polymer is or can be defined as a large molecule formed from smaller units, and the smaller units are known as monomers. Now there are two polymers that we have here. There is this polyvinyl chloride, which is also known as PVC. And I'm sure you've seen this word, especially on the buckets where we have the paints. Now the PVC has the formula given with this N. So N denotes the number of monomers that can be used. So monomers can be, you can use 2,000-3,000, depends with the requirement. So N represents the number of monomers. So now, what type of polymer is polyvinyl chloride? So this is known as the addition. So addition polymer are those polymers where you add two or more monomers, and the product is only the product is only the polymer. Then if you look at B, we can see that B, we have this box here and also this box here. Then this structure that I've circled in between the boxes is what we call a linkage. And if you look at this linkage is COO. This linkage is known as the Ester linkage. Then if we have a linkage like Ester linkage, then the type of polymer that consists of this is known as condensation polymer. Now, under condensation polymerization or polymers, the polymer is not only the product, we need to have water. So for example, if you have a monomer plus monomer and you get a polymer plus water, so as long as water is part of the product of that polymerization, then the type of polymer or polymerization that you're dealing with is condensation. Now, from this name of polymer, what do you think is the name of polymer that has Ester linkage? So these are all synthetic, they are all man-made. So this one is known as terylene. So remember, terylene has the linkage COO. So we've answered question A. Then B, what is the best method of disposing of polyvinyl and polymer B? So these two polymers, we can summarize by saying they are non-biodegradable. So what is meant by non-biodegradable? They cannot decompose by natural means. So if they cannot decompose by natural means, how can we dispose? So we can say by recycling and reuse. So this is the best method that we can use. Why? If we are to try to burn this, they are going to give us a gas that may give us air pollution. We still have the negative. So the best way is we recycle. After we recycle, then we at least make them to be used. Then for question C, name the products of protein hydrolysis. So protein hydrolysis is what happens if you add water to a protein. So protein plus water will give you the amino acids. So the answer here is just the amino acids. So amino acids are the products of protein hydrolysis. Okay, so now we have another question. Start the following sequence of reactions. So we have glucose, ethanol, ethene, polyethene. So the first question, what name is given to the process by which glucose changes into ethanol? So this is what we call fermentation. So fermentation It's just the conversion, the process by which glucose breaks down into alcohol. Then name the enzyme responsible for the change in air in one above. What gas is produced during this process? So the enzyme that we give under fermentation is zymase. Then for the gas that is produced, you just have to commit this to memory. It's just carbon dioxide. So carbon dioxide is the gas that is produced during fermentation. Name the process and the catalyst used when ethene changes into polyethene. So we know that ethene will act as a monomer. Then if ethene is a monomer, polyethene is a polymer. So the first one is name the process. So how do we convert an ethene into a polyethene? So this is by the first one, addition polymerization. So the reason why we are saying this is addition polymerization is because we are only getting the polymer as a product, no other product. Then the catalyst that can be used during this is Ziegler, a Ziegler metal. Also concentrated sulfuric acid can also be used. Then C, draw the structure of polyethene with 3 repeating units. So what does this statement mean? So let's use this. So whenever we want to use 3 repeating units, what we are supposed to do is this. So we are going to use 3 ethene. So we'll say ethene plus another ethene plus another ethene. Okay, so remember, for those that may find it hard on how to name a polymer, so the polymer is named by the first one. You just have to write the word poly. So after you add poly, you write poly, you need to add the name of the monomer. So if butene, it becomes polybutene. But in our case, this will be polyethene. So that's a pattern. That's how you name the polymers. So poly, then you add the monomer. Then if you look at the chemical formula for ethene, so ethene is coming from the family of alkenes, where we have the general formula CnH2n. And if you look at the suffix, we know that the first one, meth, has 1 carbon, eth, 2 carbons, prop, 3 carbons, but, 4 carbons, pent, 5 carbons, hex, 6 carbons, hept, 7 carbons, oct, 8 carbons, non, 9, dec, 10. So these are what we call prefixes. So the importance of the prefixes will give you the number of carbon atoms that we found in that particular molecule. So for example, we are dealing with an ethene. So let's look at this word ethene. So let's break it into equal parts. So the first one, eth. Eth means that the number of carbons we have here will be 2. Then Ene indicates or shows that this molecule is coming from the family of an alkene. So that's what you have to do here whenever you are dealing with this. So where there is the N, we can put 2. So C times 2, C2. 2 times 2, 4. So this is the molecular formula for ethene. So this will be C2H4 plus another one, C2H4, C2H4. Then how are we going to write the chemical formula? So we just have to add the number of carbons. So 2 plus 2 plus 2, we have 6. So 6 atoms of carbon total. Then for hydrogen, we can see that here we have 4 plus 4 plus 4, which is giving us 12. So that's what you do whenever you are dealing with the molecular formula. Then let's look at the structure. So the structure, we know that the alkenes will have a double bond. Now, instead of writing 3 monomers of ethene, what we can do is we can enclose this in the parentheses. Then here, this is where our Ne should be. Remember, the Ne represents the number of the monomers. But let's remove Ne, and so we know that we are told 3 repeating units. So whenever you are given this, then you put 3 here. This means that we are going to have 3 of these monomers. Now, how do you write the structure for a polymer like this one under addition? So under addition, you just have to look at the molecular formula for the compound that you formed here, C6H12. So we are going to write 6 atoms of carbon. Then remember, under addition polymerization, the double bond in the monomer will break. So the polymer must consist of only the single bonds. Then the 12 atoms of hydrogen will be here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then here, do not put anything, you just have to leave it like this. This indicates that we can still add more monomers. So this is how you can write the structure of a polymer whenever you are dealing with this. Then let's look at D. When polyethylene is burnt in excess air, 2 products are formed. Name the products. So whenever we burn something in excess air, we are going to have what we call complete combustion. And whenever we have complete combustion, the products will always be water and carbon dioxide. If these two will be our products, then it is what we are supposed to write here. So the products, remember, should be water and carbon dioxide. Though combustion will produce energy, but in our case, our focus, we just want water and carbon dioxide. And these are the products that you should have in mind whenever you are dealing with a question that tells you or that involves the complete combustion. So complete combustion, whether we have methane, alkanes, alkynes, we have alcohols, acid, anything that react with excess air under combustion will give you water and the carbon dioxide. Then E, polyethylene is a non-biodegradable substance. Explain what is meant by the term non-biodegradable and state the effect of such polymers on the environment. So non-biodegradable, non-biodegradable. So these are, we'll just say, substances that do not decompose, by natural means. So natural means, we are saying if these were to be, if you are to, like, you buy these or you just expose them on an environment, no matter how long it will take, these will never decompose. For example, if you look at a plastic does not decompose. So these are what we call non-biodegradable. Then the effect of such polymers, they are likely to cause, if discard on the environment, we may have environmental problems such as pollution, which is land pollution. If they are burnt, we may have air pollution. If thrown in water, we may have water pollution. So this is the effect of such polymers. Okay, so now we move on to another question. Below are chemical formulae of organic compounds. Okay, C2H4, CH3OH, CH3, CH2COOH, HCO2H, C2, H6. Okay, so now the first question is, name the compound which react with steam. So the compounds that can react with steam, we just have to look at alkenes, because we are dealing with the hydration here, the addition of water to form an alcohol. So we need to choose the one that we think we can have a double bond. Now, whenever you're dealing with organic chemistry, first we need to look at the valence number for each element. Like for example, carbon has a valence of 4. Thus, the carbon forms 4 bonds. So the number of bonds is determined by the valence number. If the element has a valence of 2, the total number of bonds that it would like to form is 2. If it's 1, 1. So that's a picture that you have to look at here. So if you look at the first one, so the first one, we only have 2. Let's not focus on this one. This one has OH. This one, this means that this is an alcohol. Then here we have a co, an acid. Then this should be an ester, or an alcohol. Now, so we are only interested in the alkenes. So if that is our case, let's look at the first one and the fifth one, where we have 2 carbons, but the number of hydrogen differs. So if we put the single bond here, each carbon, for each carbon to be completely filled with 4 bonds, then we can see that we need 6 hydrogen. So the first one, for it to have 4 hydrogen, we need a double bond between the carbon. So this is the first one, or the picture for the first one. Then the fifth one, this one here, we can see that we are going to have a single bond. So the answer here, an alkene must have at least a double bond. So a double bond is just this one. So we just say C2H4. Draw the structural formula of a compound which turns blue litmus paper red. So this question is same as draw a carboxylic acid, because you know that the acid has that ability. So we'll say the acid is this one. We have CH3, then CH2. Then we are going to have COOH. So this is an acid. So for you to identify an acid, you should have this functional group, which is, we call it CO. Then CO is sometimes shortened as CO2H. Don't be confused by this one. Then you choose 2 compounds which are isomers. So what are isomers? Isomers are compounds with the same molecular formula but different structural formula. So from the given list here, let's look at now how can we check for isomerism? So first begin by just looking at the chemical formula. So let's just count, let's focus on this one. Let's try this one and this one. So from this one, we can see that we have 1, 2, 3. So there are 3 carbons in total. Okay. Then what of here? We have 1, 2, 3. So even here we have 3 carbons in total. Okay, so the number of carbon atoms are equal. What of hydrogen? We have 3 plus 2. So here will give us a 5. So we have a 5 plus this one here. We are going to have the total of 6. So there are 6 atoms of hydrogen. Then let's check for the other one. 3, 5, 6. So even the hydrogen atoms are equal. So now the last one, we'll check for oxygen. We have 2. Also here we have this one and this one. So these two qualifies to be isomers since they have the same molecular formula. So that's what you do in our case. So say CH3, CH2, CH3, CH2, CO2H. Then the other one, CH3CO, CH3CO, CH2OH, CH2OH. Then the question D, which two compounds can undergo esterification? So esterification is just the formation of an ester by using alcohol and acid. So we need to have an alcohol plus the carboxylic acid, then it will give us an ester plus water. So for us to identify these two compounds, we need to look at which compound is an alcohol and which one is an acid. So how do we determine an acid and an alcohol? So the alcohol has the OH functional group, then the acid has Co, which is this one, or this one is also an acid. So say C3OH. So C3OH and HCOOH. Okay, so now we move on to another question. The structure below is for a polymer. Then the first one, name the polymer. So how can we name this polymer? First, we need to look at the monomer that was used here. So how can we identify? So let's look at this. So you can see that what I've circled is exactly the same as this one. You can look at the arrangement of the carbons, even the CH3 is also the same as this one. So whenever you do this, it will give you the picture of the monomer that was used. So this means that we have 3 repeating units. So these repeating units, it's the same as 3 monomers of the same were used. Okay, so that's a picture. Now how do we write the polymer? First we begin by writing the word poly. Then we need to look at the monomer that was used. So what was the monomer? So the monomer is one of these that I've circled. So we can just choose one. So we can say that we have, now for each monomer or repeating unit here, we can say that we have 1, 2, 3. So it has 3 carbon atoms. So the prefix for 3 I gave you is prop. Now remember the monomers for addition polymerization must be an alkene. So you just add Ene. So this is the Ene is just the suffix for an alkene. So all alkenes undergoes addition polymerization. So the name of the polymer will be the word poly plus the monomer propene. So that's what you do. Then Roman number 2, name and draw the structural formula of the monomer for the polymer. So the monomer, we've named it, it's propene. So for you to come up with the monomer, you just have to remove the prefix poly, then you get whatever that remains. So name, we have named, draw the structural formula. So the structural formula, you just have to look at the way the carbons are arranged. So we can see that they are like this. We have this one, also this one, then there is another one like this. Now remember, if you are dealing with a monomer, you need to bring back the double bond. So there was a double bond before the polymerization. Then here you put the hydrogen. Also here you put the hydrogen. So this is the displayed structural formula. Then state the type of polymer that is shown above. So the type is addition. How do you know that it's addition? All alkenes forms addition polymers. So during their polymerization, water is not formed. Then give one use of the polymer. So these polymers can be used to make plastics. Okay, then we have C. Ethanol is an alcoholic beverage which can be brewed from cassava. Outline the process by which ethanol can be prepared. So here you just have to look at the fermentation. So the first one, you just have to say the glucose or starch is broken down by putting it in warm water. Then after that you add the yeast, which will act as a catalyst. Then from there you need to make sure that you cover where you are doing your preparation of alcohol by preventing oxygen from entering the mixture to avoid oxidation. So we are saying the first one, you break down the complex carbohydrate by heating the mixture in hot water. Then the second one, you add the catalyst, which is the yeast. Then from there you need to make sure that after the mixture is heated to that favorable temperature, keep it on a warm condition or a favorable condition, where the condition should not be high, also not low. It has to be a favorable one. Then cover it to prevent oxidation. Then we have the question D. Ethanol is used as a fuel. Construct a balanced chemical equation for its complete combustion. Remember, combustion, we said we are going to have the water and carbon dioxide as the product. So ethanol has this formula. It's C2H5OH plus C oxygen. This is combustion. Then we get carbon dioxide plus C water. Then from there, what you just have to do here is you just have to make sure you balance. So how can we balance? Let's put 2 here so that we have 2 carbons. Then we put 3 here. 3 times 2, we have 6. Then also here we have 5 plus this one, 6. Then what of oxygen? 2 times 2, 4 plus 3, 7. So we just want a 3 here, so that 3 times 2, 6 plus this one here, 7. So this is our balanced chemical equation for this reaction. Okay, so then for if you maybe forget this chemical formula for ethanol, what you do is at least you should be able to remember the general formula for alcohols, which is CN H2N plus 1 OH. Then from ethanol you get eth. Eth means we have 2, so while there is any, you put 2. So C times 2, C2. 2 times 2, 4 plus 1, 5, OH. So this is where the chemical formula is coming from. So now we have here nylon and terylene are polymers. What is meant by the term polymer? So a polymer is defined as we say is a long. So it's a long chain structure of organic that may repeat throughout the structure. So that is what we can look at here. Now, apart from being polymers, give one similarity between the two. So between nylon and terylene. So we can see that they are both made by condensation polymerization. So that's a similarity, meaning during their formation, water is also formed. So nylon is a condensation polymerization, so is terylene. Then the other one is they are all synthetic, means that they are man-made, synthetic. Then C1, which of the two polymer is a polyester? So a polyester is, we want the one that has an ester linkage. So from there, an ester linkage is found in terylene. Okay, then hence draw the structure of the polymer shown two repeating units in circle and ester linkage. So how can we draw the structure of terylene? So terylene, remember we are saying terylene, for us to produce terylene, first we need to look at first condensation polymerization. So under condensation polymerization, first we are going to look at what are the monomers that we are supposed to use for us to have terylene. So the picture here is this. So terylene can be formed by, you can say an alcohol, or maybe you can just say a diol. So diol plus carboxylic acid. Carboxylic acid will give us the terylene plus water. Okay, so hence draw the structure of the polymer showing two repeating units, then in circle and ester linkage. Okay, so the structure for diol is this one, so you just have to commit this to memory, and it's the same as the glucose. So diol plus, if you look at dicarboxylic acid, it is just a function, a chain where we are going to have two functional groups for an alcohol. So an alcohol has this one alcohol function. So since it's di, we are going to have two. Over here I forgot to put di. Now how do we do this? So it is just simple. So from the alcohol you remove hydrogen, then from the carboxylic acid you remove hydroxide. Why? We need to remove whatever that is forming water. Then we will attach whatever that remains. So the picture is, you say, so we have this box, then this bond, we have this oxygen here, then the half will bond with the other half, so give us this one, then followed by this, then a box. Now since we are saying two repeating units, let's make another of this. So this is what you do. Then the other is in circle and ester linkage. So the ester linkage is anything in between the boxes here. So this is our ester linkage. So it's a linkage because it's holding two of these boxes. Sometimes you may encounter a question where one box is shaded. It's not a big issue. So the key point is an ester linkage has the chemical formula of COO. Then maybe let me give you where you can find an ester linkage. Ester linkage is the first one found in pterylene, then the second one in fats, then also in esters. This is where you can find this type of linkage. And you may also given a question, you are given this structure and the question is just draw the ester linkage. So this is what you have to do. Okay, so now we move on. The series of processes below shows the links to the formation of an ester known as ethyl ethanoate. Then let's look at this series. Ethene, process K, ethanol, process L, product P, process M, ethyl ethanoate. So let's look at this one. Here we know that this is an alkene. Then this is an alkano, or we'll just use the common one, alcohol. So P should be carboxylic acid. Then this one is an ester. Whenever you see ethyl, propyl, methyl, that's an ester. Then question A, from the reaction scheme above, name the processes K. So by what process can we convert K? I mean, by what processes can we convert ethene into ethane? So it is hydration or hydrolysis. We just add water. So hydration. So whenever you add water to an alkene, you form an alcohol. What of L? How can we convert an ethanol into an acid? So by oxidation. Then M. How can we convert a carboxylic acid into an ester? Through esterification. Then B, construct the equation, the chemical equation describing process K. So what is process K? Process K is just the hydration. So what do you do? We know we have ethene plus C, water. So what do you get? You get ethanol. Then ethene is C2H4, a gas, plus H2O. Also this is a gas because it's steam. Then ethanol is C2H5OH, which is a liquid. And for these kind of equations, they are already balanced. So that is what you just have to look at here. Then state both the chemical name and common name for substance P. So substance P is ethanoic acid. So chemical name is ethanoic acid. Then common name is acetic acid. Set the general formula of the series where substance P, so the series is CN, H2N, Q. Then state N2 uses of ethyl ethanoate esters to make perfumes because of the nice smell, then to also use to make food flavoring, also in drinks. Okay, so now the diagram just shows an arrangement of outermost electrons in a molecule of a compound. Okay, then A1 on the diagram indicate a double covalent bond by putting a circle around it. So how do you know that there is a double bond? So for you to identify that there is a double bond, you need to look at where there are 4 electrons, because each bond has 2 electrons. So even these 2 electrons. So whenever we have 4 electrons, that is an indication of a double bond. So at this point here, this is a double bond. Then construct the chemical formula of the molecule above. So we'll first begin with the carbons. How many carbons? So you can see we'll have 1, 2. So say C2. Then we'll look at these 3 hydrogens. So we'll look at these 3 hydrogens. They are on their own. So put 3. Then from there we have OO, which is O, this O, and also this O, H. Now, if you want to write it the usual way for an acid, this is just C, CH3, COOH. That is the usual way. Then calculate the molecular mass of the molecule. So molecular mass, how can we calculate this one? So we'll just say Mr is equal to, so say carbon times, we have 2 atoms of carbons, plus let's say hydrogen times how many atoms of hydrogen altogether. So we have 1, 2, 3, 4. So we have times 4 plus then what else do we have? Oxygen times they are just 2, 1, 2. So the mass number for carbon is 12 times 2 plus 1 times 4 plus 16 times 2. So 2 times 12 will give us 24 plus 4 plus 32, which is 24 plus 4 plus 32. I'm getting 60 as, according to my calculator, I'm getting 60 as my final answer. So that is the molecular mass is just 60. Then to which homologous series of compounds does the molecule belong to? So whenever there is COOH, then it is a carboxylic acid. Or sometimes they have their organic name, they are known as alkanoids. Then state one property of the molecule. So it tends, or we can just say it tastes sour because of the acidity. Okay, so we have another question. Butene C4H8 is a compound belonging to the alkenes series. Okay, so here we have 4 carbon atoms, 4 hydrogen atoms. So now if we are to divide this name, so the first but or but is just the prefix. So it's just the prefix, and this tells us that there are 4 carbon atoms. So that's what you have to look at here. So the but shows 4 atoms. Then Ene indicates the suffix, which is the family where it is coming from, which is an alkene. Now the first one, set the general formula for all the alkenes. So the formula that you are supposed to commit to memory is CnH2n. Draw the displayed formula of the second member of the series. So for us to draw the displayed formula, first we need to look at the molecular formula. So let's write our formula. We know we have CnH2n. Since we are told the second formula, this means that where there is N, we put 2. So this will give us C2, 2. So C times 2 will give us C2, 2 times 2, 4. So this is what we are dealing with. Now the displayed formula, same as the structure. We need to now form the structure. Now there are 2 carbon atoms. Remember to put the double bond whenever you are dealing with an alkene. Then here we just put 1, 2. So we can see that each carbon is filled with a number of carbon bonds. Then for C, butene is prepared by cracking petroleum oils. Name the other method by which it may be prepared. So apart from cracking, butene can be made. So butene can be made from, we'll just say, dehydration. So dehydration of butanol. So what is butanol? Butanol is an alcohol. Then what is dehydration? What happens if you remove water from a butanol? So whenever you remove water from an alkane, you form an alkene. So we can form that in such a way. Then but1 can be polymerized. So what is that? What does this number means here? So let's look at but. So but, if you are to draw the structure, we are going to have 4 carbon atoms. Now whenever we have a number here, the number is indicating where the carbon double bond is. So if this is our, let's say this is our carbon 1, carbon 2, carbon 3, carbon 4, you can number from the left to right or vice versa. So whenever you are given a number, that is where the double bond is. So the double bond must be on carbon 1. That's what the number is telling you. So that's what it means. So this is how our structure is. Now we have Roman number 1. Name the type of polymerization it undergoes. Remember, I said all alkenes undergoes addition polymerization. You don't have to even think of condensation here. No, it's addition polymerization. Draw and give the name of the polymer formed from but1. Show at least 3 repeating units. So let's maybe have enough space here. So we are saying but. So let's just see, shorten. So butene plus C, butene plus C, butene. This will give us the name of the polymer is polybutene. So I said you begin with poly, then you add the monomer. Then the chemical formula for butene, we are given C4H8. So C4H8. So let's add the carbon atoms together. So this 4 plus 4 plus 4 will give us 12. Then 8 plus 8, 16 plus 80, 24. Then how can we write the monomer? So the monomer is butene. So we have C. So let's maybe make it like this. So this will be our monomer. Now since we are told 3 repeating, let's put 3 here. So remember, whenever we are now drawing the structure of the polymer, you need to arrange the same way the monomer is. So 1, 2, CH3, CH3. Again 1, 2, CH3, CH3. Again 1, 2, since we are using 3 repeating units. And remember again, no double bonds in the polymer. So now you can just finish by you put the hydrogen atoms so that each carbon is now satisfied with 4 bonds. So this is our displayed. So we have drawn and give the name. So the name is polybutene. Okay, we are done with that one. Then butene react with steam in the presence of a catalyst to form a colorless compound. So name the compound formed. So this will give us butanol. Remember, whenever an alkene reacts with steam, which is water, you get an alcohol. So butanol. Write a balanced chemical equation for the reaction between ethanoic acid and compound above, including state symbols. So how can we write this one? So balanced chemical equation. Ethanoic acid. Okay, let's begin by ethanoic acid is CH3 COOH. All acids are in aqueous phase, plus butanol will be C4H9OH. So whenever you react an acid and an alcohol, you are going to form an ester. So you do the same. We need to remove what is forming water. So from this party we remove hydroxide, then from the alcohol party we remove the hydrogen, then the remaining is CH3 COO CH9 CH4 plus H2O as our final answer. So acid react with an alcohol to form an ester. Then if the question is what name is given to this process, is known as esterification. So start the following series of reaction for ethene. So we can see that add bromine plus water, we get liquid F. Then this one no plus steam, liquid E. Then excess oxygen and ignite, gas B plus steam. Then add. Okay, so now let's look at the questions. So identify gas A. Gas A, the gas that can be added to change an alkene. So look at the pattern here. We have an alkene, Ene. So how can we convert Ene to Ane? So we are converting from an alkene to alkane. So this is what we call, the process is known as hydrogenation. So hydrogenation is just the addition of hydrogen. So gas A is hydrogen. Then gas B. So gas B, let's look at the name. There is ethane, there is chloro. So chloro is just chlorine. So gas B is chlorine. Then gas C. Gas C. Oh, sorry, I'm sure I've made a mistake. I've answered not Let's go back. So gas B is what we were looking at here. So let's go back. Gas B is this gas here. So what gas is produced whenever you add excess oxygen and ignite to ethene? So this is now combustion. So what are the products of combustion? So combustion, complete combustion gives us carbon dioxide plus water, which is steam. So gas B is carbon dioxide. Then gas C is chlorine, from the word chloro. Chlorine. Then what else? Condition D. So condition D, for an alkane with ANE to undergo addition, we call this as substitution reaction. To undergo, there should be the presence of ultraviolet light, so UV light. Then liquid E. So if you add water, which is steam, to an alkene, you form an alcohol. So ethene becomes ethanol. So we have ethanol. Liquid F, you add bromine to an ethene. So this is what we are going to have dibromo ethane. And remember, it's colorless. And this is one of they use to check for an alkene. Then write a balanced chemical equation for the reaction of ethene with excess oxygen. Remember, this is combustion. So ethene is C2H4 plus O2. The products, we get water, which is steam, plus carbon dioxide, which is a gas. Then where are we supposed to put the numbers? So we put 2 here, so that 2 times 2 we have 4. Then we can also put 2 here, 2 carbon. Now 2 times 1 here, so there are 2 atoms of oxygen in water and 4 atoms of oxygen in carbon dioxide. So total we have 6 atoms of oxygen on the right side. So we just need a 3 here, so that 3 times 2 we get our 6. Give the structural formula of liquid E. So liquid E is ethanol. So the chemical formula, first we'll begin by the chemical formula, C2H5OH. Then the displayed structural formula is this. So under alcohol, remember to put the single bonds between carbon atoms. Then plus the OH here. Set the industrial application of the reaction of ethene with gas A. Ethene with gas A. So gas A, we say the hydrogen. So what happens if we add hydrogen to ethene? We form an alkane. So the industrial application manufacturing of margarine. That's why one of the use of hydrogen is to manufacture margarine. Then for dibromo, I want maybe to look at the picture. Let me show you what is happening here for you to have dibromo. So we have ethene, C2H4 plus bromine. Remember, bromine is an halogen, and all the halogens are diatomic. So we are going to have C2H4Br2. So since there are 2 atoms of bromine, thus the name dibromoethane. Okay, so the structure displayed below is a polymer that was formed from monomer Y. name the polymer. So we know that for us to name the polymer, we need to begin by poly. Then let's do this. I told you what to do. You need to circle these so that you have the same repeating unit. So now, for you to identify the monomer, you just have to count the number of carbons from each circled part. So we have 1, 2, 3. So 3 is Prop, which is propene. So name the monomer is just propene. Then you construct the displayed structure of monomer Y. So monomer Y will just be propene. We are saying 3 carbons. Remember to put a double bond since these are alkenes. And under this one, doesn't matter where the double bond is because you are not given a number, so we can put wherever. Okay, so that is the structure. Then monomer Y was reacted with steam under suitable conditions and an organic compound Z was produced. Remember, an alkene reacts with steam to form an alcohol. So to which homologous series does Z belong? So it is alcohol or alkano. Write the general formula of the homologous series stated in C1. So is Cn H2n plus 1 OH. So a hydrocarbon V, which contains only 3 carbon atoms, was bubbled through bromine solution, and there was a rapid decolorization of the solution. Identify the hydrocarbon V. So here we know we have been given n is equal to 3. So when n is equal to 3, it's prop. Remember that. So we are going to have prop. Now, since there was a decolorization, meaning the color of bromine changed from brown to a colorless, this means that this should be an alkene. So this is propene. Draw the structure of the hydrocarbon V. So first, let's look at the formula, molecular formula. So the molecular formula is we are going to get, we have CnH2n. So n is equal to 3, we say C3 2 times 3, which is C3H6. So write 1, 2, 3. Whenever you're dealing with a structure, first begin by writing the carbon atoms. So then we are going to have a double bond. Make sure each carbon has 4 bonds. So 1, 2, 3, 4, 5, 6. So this is our structure. Then to which homologous series does the hydrocarbon V belong? Since there is a double bond, it is an alkene. Write the general formula of the homologous series where the hydrocarbon V belong. Is Cn H2n, like this. Then B1, explain the danger of burning the hydrocarbon V in limited oxygen. So it may produce carbon monoxide. So whenever we have insufficient, we have carbon monoxide. Then carbon monoxide may cause suffocation to humans. So may cause suffocation. Write the balanced chemical equation for the reaction in B1 above. So we know that we have C3H6 plus O2, then CO. Here we are getting carbon monoxide plus H2O. So remember, the only difference here, is just complete combustion will give you carbon dioxide plus water. Incomplete will give you carbon monoxide but CO plus water. So let's put 3 here. So if we put 3 here, 3 carbons, let's also put 3 here, so that 3 times 3 will give us 6 atoms of hydrogen. Then oxygen will have 3, so we just put 3, 3 times 3, 3 times 2, 6. Then here we have that. Then under suitable conditions, the hydrocarbon V was polymerized and polymer W was produced. So display the structure of polymer W. So here we are not told how many monomer we are going to use, so let's just use 2. So CH3. So by now I'm sure you've gotten the picture. So let's just put, okay, let's just use 3. So okay, so this is our answers for this question. Okay, so now the following diagram shows some of the reactions of ethanol. So oxidation, solution B, process Q, ethene, then complete combustion, we have gas R plus water. Then draw the structure formula of ethene. So ethene, because of Ene, is an alkene. Alkene obey to this general formula. And Eth means N is equal to 2. So let's first make the molecular formula. It's important you do that. So C times 2 is C2, 2 times 2, 4. So we have 1, 2. Remember to put a double bond. Give the name for solution P. So solution P will have oxidation. So what happens to an alcohol if it undergoes oxidation? It forms ethanoic acid. Process Q. So ethanol changes from ethanol to ethene. So that is, if we remove water from an alkane, we form an alkene. So this is dehydration. What else? Okay, so gas R. Complete combustion will form water and carbon dioxide. So gas R is carbon dioxide. Write a balanced chemical equation for the complete combustion of ethanol. So ethanol is C2H5OH plus CO2. Remember, we get carbon dioxide plus H2O. So what are we supposed to do? We put 3 here so that we have 6 atoms of hydrogen, 5 here plus this one, 6. Okay, then what else? Let's balance carbon. So 2, 2, we need a 2 here. Now 2 times 2, 4, plus 3, 7. So there are 7 atoms of oxygen on the product side. So we just put a 3 here. 3 times 2, 6, plus this one here, 7. So our equation is now balanced. Okay, so now the 4 hydrocarbon given are members of homologous series. Explain the term hydrocarbon. So these are molecules. which contains hydrogen and the carbon atoms only. Okay, so these are what we call hydrocarbons. So there are only two types of atoms, the ones for hydrogen and for carbons. Name the first one, homologous series to which the above hydrocarbon belong. So the first one, no, CH4. So we need a structure like this. And you know that if you look at these, we have single bonds, so these are just alkenes. Then name the compound with the molecular formula C4H10. So from the prefix that I gave you, meth 1, eth 2, prop 3, but 4. So we have but. Now since there is a single bond, we add ANE, so butane. Draw the full structure formula of the hydrocarbon which has 4 carbons. So 1, 2, 3, 4. Under alkenes, you put single bonds between carbon atoms. Then 1, 2, 3, 4, 5, 7, 8, 9, 10. So which of the given hydrocarbon has the highest boiling point? So for you to determine the highest boiling point, you just have to look at the one with the highest number of carbon atoms, which is this one. So C10, H22. Okay, now we move on to the last question here. Both fats and proteins are natural polymers. So if we compare these, you'd find that if we looked at pterylene is a condensation polymer, and a nylon is also a condensation polymer. Now the only difference is that pterylene and nylon are man-made. They are made by men. Then fats and proteins are just natural, made by our oh my God. Then name the synthetic polymer that has the same linkage as. So the word synthetic means the man-made. So that has the same linkage as the fats. So in fats we have ester linkage. So which man-made has an ester linkage from pterylene and nylon is pterylene. So the similarity between fats and pterylene, or the similarities are: number 1, they are all condensation polymers. Number 2, they have the same linkage. Then for proteins we have amide linkage or polyamide if it's so long. Then we have here it's nylon. So nylon and proteins, they share the same linkage. The first one, B1, draw the type of linkage found in the synthetic polymer named A1. A1 is ester linkage above, and name the linkage. So the name, we know it's ester linkage. Then the structure is like this. We have C like this. Remember, this is our ester. Then synthetic polymers are non-biodegradable. What is meant by this statement? So this statement means that they cannot decompose by natural means. The structure displayed below is for another natural polymer. Okay, name this polymer. So whenever you see a linkage in between the boxes, it's just this is a carbohydrate, or maybe you can use starch. Is this polymer an addition or condensation polymer? Give a reason. So this is a condensation polymer. Reason: because we can say because it's heated, it's softened when heated, or because during its formation water is formed. Then draw the structure of the monomer used to synthesize this polymer. So we know that we are looking at the glucose. So the glucose has this structure like the dial where you have the box. What type of linkage is found in this? This one is known as so we are dealing with a glycosidic bond. Okay, so this is what I just wanted to share with you. So that's it for this video. Thanks for watching.